Hi, my name is Tullius, and I will be explaining parts 1 and 2 of our Rube Goldberg system. In the first event, the pencil case was pushed down the ramp toward the truck. Looking at the free body diagram after defining our positive and negative directions, there is a normal force pointing up perpendicular to the surface of the ramp, a force due to gravity that points vertically downward, which is split into the x and y components of force due to gravity. The x component is along the surface of the ramp, and the y component points down perpendicular to the surface of the ramp. And then there is a force from the push in the negative direction along the ramp, and a force from friction in the positive direction along the ramp. This leads to the x and y component net force equations. X component net force is force of friction minus force of push minus x component force due to gravity equals m times a. And the y component net force is normal force minus y component force due to gravity equals 0. Before the push, kinetic energy is 0 and there is gravitational potential energy. And after the push, there is a positive work from the push, which increases kinetic energy. The equation for the work is work equals force times displacement times cosine of theta, where theta is the angle between force and displacement. Hi. In the second part, the pencil case is rolling down the ramp, where there is a force from friction between the computer and pencil case. In this case, kinetic energy's increase is slightly less due to the energy lost with friction, which is instead likely converted to thermal energy. The network equation with friction in mind is network equals work from push minus work from friction. Along with this, the velocity is at a constant speed while the acceleration is increasing, both in the same direction.
This is Reagan, and I'll be doing parts 3 and 4 of explaining the machine. In part 3, the pencil case is rolling down the frictionless ramp after a push at the top of the ramp and is hitting the truck. This collision with the truck can be considered to be an inelastic collision. While at first glance it may appear elastic, in an inelastic collision, momentum and kinetic energy are fully conserved, which would mean the objects would collide and then reverse in direction. In this case, the pencil case should fully stop after hitting the truck instead of continuing to move forwards. However, this is not the reality, as the pencil case continues to move forward after colliding with the truck. Some of this kinetic energy may be lost to slight deformation of the material of the pencil case. An example of an elastic collision would be two billiard balls colliding. Since the pencil case continues to move after the collision, we could assume that the mass of the pencil case is greater than the truck. Also, as we watch the pencil case roll down the ramp after the push, there is gravitational potential energy and kinetic energy since it is in motion, and since there's some height from the ramp. After the collision, the truck and pencil case have kinetic energy, but no gravitational potential energy, establishing the track at a height of 0. Moving on to the next collision, the truck with a thumbtack moves along our track and strikes the balloon sitting at rest. As this balloon is blown up in the making of the machine, its elastic potential energy increases. Once the thumbtack strikes it, kinetic energy increases and potential energy then becomes 0. This mechanism carries similar logic that springs do. As a spring is compressed, its spring potential energy increases, then the potential energy is lost to kinetic energy as the spring is released. As a result, this collision is inelastic. Kinetic energy is not conserved, and instead some of this energy is transferred to sound, as the balloon popping ended up being quite loud, and other energy being transferred into deforming the balloon from a fully intact spherical shape to different pieces broken apart. It is not perfectly inelastic, however, because the objects do not hit each other and continue moving together. The truck will also continue to roll after hitting the balloon due to the nature of this collision.